All right, guys, so lesson 6 today, and I'm going to start off with just a little piece of a rhyme. My homeroom, or my team, I should say, shouldn't be surprised by this, but absolute value is the distance from zero. It's a positive number, and it's my hero. Absolute value is the distance from zero. It's a positive number, and it's my hero. An easy way to remember that when we are working in absolute value, as it says up at the top, we're going to be working with positive values, and I'll explain what that means as we go through. But that little rhyme, you're going to hear me repeat it as I go through this lesson, and it's hopefully a mnemonic device to help kind of stick that idea in your brain. So we're going to jump right down to 6.2. So I'm going to scroll down a little bit to this jumping flea. And all right. So we've got a number line, and a flea is jumping around. If the flea starts at 1, and jumps 4 units to the right, where does that flea end up? So starts at 1, jumps 4 units to the right, 1, 2, 3, and 4. That flea is going to end up at the 1, 2, 3, 4, 5, fifth spot there. So where does it end up? 5. How far away from 0 is this? Well, if it's the fifth tick, it's 5 spaces away from 0. So the first answer is 5. The second answer is also 5. It lands on 5. That's 5 spaces away from 0. If the flea, however, starts at 1 and jumps 4 units to the left, so all right, I'm starting in that same spot, but now I'm going left. 1, 2, 3, and 4. Where I'm ending up there is actually 1, 2, 3 spaces behind the 0. So that's going to be back there at -3, because when I count behind the number line to the left, my numbers get lower. So I'm going to go -1, -2, and -3. So I would say that he ends up on -3 as his location. How far away from 0 is this? Well, his distance from 0 is 3 spaces away. So how far from 0 is he? 3 spaces, or 3 ticks, 3 hops. Man, my handwriting looks awesome on here. Part C, if the flea starts at 0, all right, switching colors again, and jumps 3 units away, where might he end? Okay, notice it doesn't tell us left or right this time. So if I start at 0, and hop 3 spaces, 1, 2, 3, this way, I'm going to end up back at -3 again. However, if I start at 0 and hop 1, 2, 3 spaces to the right, I would be ending up at +3. So depending on which direction this little flea hops is going to vary in his value. So where might it land? It might land at -3, or it might land at +3. Then if a flea jumps 7 units and lands at 0, where could it have started at? Okay. Well, if it hops 7 units, it lands at 0. If we start at 0 and go 7, we'll end up kind of going opposite and figuring out where it was. I think I'm going to erase all this other stuff first, because there's already a lot going on that number line. And we're going to be doing some more moving. So okay, so this is where we want to land this time according to part D. So 1, 2, 3, 4, 5, 6, and 7. So if I can go this way, 7 spaces, and land at the 7 spot, if I start there and move the opposite direction, so if I start here and go backward 1, 2, 3, 4, 5, 6, and 7. It's actually really hard to trace my own lines on touchscreen. So I can see there's a gap of 7 there. Whether I start at 0 and go to 7, or start at 7 and go back to 0, I'm still making 7 hops. So that flea could where could it have started? Well, it could have started at the 7, but he could also be making that jump going the opposite direction. So I could also say that this little flea dude could have gone, there's 0 again. 1, 2, 3, 4, 5, 6, and 7. So that little flea could have started 7 spaces away, but in that opposite direction, meaning that it would have started at a negative number, a -7. So it could have started at +7, or it could have started at -7. Either way, its distance from 0, or to 0 in this case, because it says it needs to land there, it needs to go there. Either way, that distance that it's hopping is going to be the same. So, I hate that I have to erase to scroll, but it's what I've got with the program I'm using. Maybe I'll find something better in the future, but for now, I'm working with what I've got. All right. So I'm going to come down and, oh, we're still have a few more things with the flea. So the absolute value of a number is the distance from 0. Like I said, absolute value is the distance from 0. It's a positive number, and it's my hero. The flea is currently to the left of 0, and the absolute value of its location is 4. Now, one thing to make sure you know, and okay, we're going to start to see it down a little bit lower. This term that's bolded, of course, is one that it's going to be a vocabulary term that you're going to be expected to know because it's going to be coming up quite a bit. Other than just saying the absolute value, there's a symbol that shows us absolute value. So anytime you see a number that is inside of 2 darker lines, could be any number, I'm going to put a 6 in there, those dark straight lines surrounding it, like this, kind of like a railroad track going around it, is a symbol that means absolute value. So just be aware, and we're going to see that down below. I see on question number 2 at the bottom of our page right now that we're going to start to see that symbol in there. The flea is currently to the left of 0, so if I come back to E, if it's to the left, left is less. Left is less. Think LL, left, less. So if he's to the left, he's on that lower number side, so he must be on the negative side of the number line. And he's 4 units away. Well, on the negative side, the number that would be 4 units away from 0 would be a -4. If the flea is to the left of 0 and the absolute value of its location is 5, where on the number line is it? Okay, so its absolute value is positive, 5. That's a positive number, a regular plain old whole number. But it says that we are again to the left of 0. It's important to pay attention to that because left is less, left is lower. If we're left of 0, 5 spaces, we're 5 spaces behind, which means that we are -5. And if the flea is to the right of 0 and its absolute value of the location is 2.5, where on the number line is it? Okay, don't let that decimal fool you. Absolute value is probably the easiest thing you're not only going to do in 6th grade, but probably the easiest math thing you're going to do for a long time. Whether it's got a decimal, a fraction, don't let that be confusing. We just need to know, are we positive or negative? And it's whatever it says there. So it's to the right of 0. All right. Well, if left is less, then right must be greater. So this is on the positive side, and it's 2.5. So guess what? We're just going to leave it positive 2.5 because now we're on the right side of the number line. Erasing so I can scroll up, and we're going to look at one last thing with absolute values, kind of using that symbol there. But absolute value is the distance from 0. It's a positive number, and it's my hero. And if you can figure that part out, you're going to be just golden for this activity and this assignment. We use the notation absolute value of -2. So that's what I was telling you a moment ago. That is the symbol that means absolute value. So those 2 lines straight around the number. We say absolute value of -2, which means the distance from -2 from 0 on the number line. So what does the absolute value of -7 mean, and what is its value? Well, that symbol tells us that the absolute value, so the, wow, distance, I'm always impressed by what my handwriting looks like on this. Distance, I need one of those pens that has like the little stylus on it. Yikes. The distance from 0, and absolute value is the distance from 0. It's a positive number and it's my hero. So no matter whether the numbers inside of that symbol are positive or negative, since we're just talking about distance, not value, its distance is always going to be positive. So this number would be 7 units from 0. So the answer to this, its value would just be 7 in the positive direction. And here again, don't let decimals and fractions scare you off or confuse you. 1.8 is 1.8 away from 0. So the fact that there's a decimal in there doesn't need to complicate this at all. It means that the absolute value of 1.8, 1.8 is 1.8 units from 0, and its value is still 1.8. Always going to be a positive. Absolute value is the distance from 0. It's a positive number, and it's my hero. As we move into 6.3, we're looking at elevation and temperature and how we can use absolute value in these different situations. So, a part of New Orleans is 6 feet below sea level. That's true. That's why Hurricane Katrina was so devastating. We can use -6 feet to describe its elevation and the absolute value of -6 feet to describe its vertical distance from sea level. In the context of elevation, what would each of the following numbers describe? So 25 feet, there's no negative on that number, so it's a positive number, meaning that it must be 25 feet up, since we're talking elevation. So this must be 25 feet up above its kind of starting point or its 0 point. So this would be 25 feet above sea level. 25 feet above, oh man, guys, I am so sorry. Sea level. I don't even know if it's worth me trying to write this. It's so bad, but hopefully. Then on B, we've got the absolute value of 25 feet. So we've got absolute value is the distance from 0. Okay, 25 feet. So it's a distance from 0. It could be 25 feet above sea level, or it could be 25 feet below sea level. Because again, if sea level with elevation, sea level is what we use as kind of our baseline, our starting point. So it could be 25 above or below that sea level point because it's absolute value. So it's just distance, doesn't necessarily, we don't know which direction they're thinking there. With -8 feet, well, we don't have that absolute value symbol on here. We're working in a negative number. That number is definitely going to be down, lower, or below. So this would be 8 feet below. I'm trying to use the mouse now and see if that's any better than the touchscreen, because yikes. Better, but slower. Below sea level. All right, I'm going to find a stylus before I record another one of these, because this is just bad. Below sea level, L level. The absolute value of -8, okay, absolute value is the distance from 0. It's a positive number and it's my hero. In other words, we are 8 units away from 0. The absolute value of -8 is still 8 units. Even though it starts out with a negative, it's beginning in that negative direction. However, the distance from 0 is 8. So when we have the absolute value of 8, we're just saying that it is 8 feet away from that 0 point, away from, and in the context of elevation, that 0 point is going to be sea level. So this would be 8 feet away from sea level. And if we go down just a little bit further, last thing, I know I'm probably getting close on time here. When we see it in the context of temperature, then, That's going to have us thinking, so number-wise, values are the same, but when we think about it in a different context, so using a different label or in a different situation, we just kind of need to think like, what does zero mean here? Or what are we comparing against? Because sea level no longer applies when we start to talk about temperature. So I'm looking at question number 3. If we write -5 degrees Celsius to describe the temperature that is 5 degrees Celsius below freezing, and 5 degrees temperature for a temperature that is 5 degrees above freezing, in this context, what do the following numbers describe? Well, if -5 is below freezing, 5 below to be specific, and regular 5 degrees, positive 5 degrees, is 5 degrees above freezing. Well, then each time we're 5 away from our starting point. We talked about being above freezing or below freezing. So that's going to kind of tell us that our zero here in Celsius, which is true, Celsius makes a lot more sense than Fahrenheit. 0 is the freezing point, not 32 like our weird Fahrenheit system, but 0 degrees Celsius is freezing. That's the freezing point. Doesn't feel any different, it's just that it's measured differently. Like when you hold up a thermometer and one side of it is read with Fahrenheit degrees and one side of it is read with Celsius degrees. So it still feels the exact same, but it's just the way that it's discussed or calculated or measured at. So 1 degree Celsius then, all right, we've got a positive. If 0 is our kind of baseline for freezing point, 1 is a positive number, which is going to be above or higher on that thermometer. So we're going to be 1 degree above freezing. Whereas part B, -4 degrees, well, again, here's freezing, 0 is 4 below that. So we're going to be 4 degrees below freezing. Everything is going to be frozen solid at that point. If we look at part C, where we've got the absolute value of 12, well, an absolute value, it's a distance from 0. So we could be 12 above or 12 below. So the absolute value of 12 degrees Celsius is going to be either positive 12, 12 above, or -12, 12 below, because that absolute value is just the distance from 0. It ends up being a positive number because we're going to talk about it as just being 12 units away. And finally, -7 degrees Celsius, well, actually the absolute value of -7 degrees, we're going to end up 7. That absolute value ends up being a positive number, so just meaning 7 units. We're going to kind of ignore that negative when we're inside of that absolute value symbol and just say that we're going to end up 7 units away from 0, 7 units away from that freezing point. So we can either be 7 degrees above or 7 degrees below, or a distance of 7 units in either direction. Any questions about this one? I feel like you guys should probably be okay with this one, but as always, hop on with math help with us if any of this doesn't make sense, or email your teacher for clarification. So hopefully that's enough to get you going on this. If you're going the practice problem route, today's practice problems are numbers 1 through 3, or you've always got a Khan Academy that you could do, or you could do some Freckle for practice on this, but make sure you do some independent practice. See you next time. Bye.